Welcome to Cookies Maths and Science Hub. Today we'll be learning all about acids and bases. Let's start off with a basic dive into what acids and bases are. Acids are what we call proton donors, meaning in reactions they donate a proton. We can represent a proton using H+, and this is often how we represent acids as well. They are corrosive in nature and often molecular in their structure. Acids can be neutralized by a base, meaning that if you add a base to an acid, it will neutralize to water. Certain dyes change color in the presence of an acid. This allows us to use these dyes to detect for an acid in certain situations. Now, acids taste sour, however, I would not recommend tasting many, but some you would more commonly eat, such as vinegar, which is one of the more common examples. Some other examples include hydrochloric acid, sulfuric acid, and carbonic acid, which we can find in soft drinks. Bases, on the other hand, are proton acceptors. This means they accept a proton within reactions, often with acids. We represent them with an OH-, as if you think about a neutralization reaction, that is an acid and a base, OH- plus H+ gives us our H2O, which is the water that is the neutralization of an acid and base together. They are also corrosive and are often oxides and hydroxides of metals. Much like acids, certain dyes change color in the presence of a base, allowing us to detect when a base is present. However, bases taste bitter. Again, not advising you to taste them within the lab or any of the examples. Some examples include sodium hydroxide, which is Drano or a type of cleaner, sodium bicarbonate, which you might use as baking soda, or might know as baking soda even, and lime, which is calcium hydroxide. You can see there that these are hydroxides and carbonates, as we just mentioned. The pH scale is a measure of the H+ ions present in a solution. But for now and for this video, we're just going to mention that it is a scale that measures the acidity of a solution. Acids have a pH less than 7, and bases have a pH greater than 7, with neutral solutions having a pH of 7. The scale to the right is based on the colors of what we call universal indicator, with it moving from red through to violet based on what number the pH is. Now, as I said, we're only covering this very basically in this video, but there's a lot of different complexities with the pH scale that we'll cover in its own video in another time. Some acids are considered weak while others are considered strong, and the same can be said about bases. What we mean when we say strong acid or base is that it fully dissociates, that means to break down, into H+ ions and OH ions respectively when mixed with water. For example, if we were to place HCl, which is hydrochloric acid, into a solution of water, because it is a strong acid, it will fully break apart into H+ ions and Cl- ions. Weak acids and bases, on the other hand, only partially dissociate. This means they don't fully break down into the OH ions and the H+ ions. An example of this is if we have aluminium hydroxide, or AlOH3. That breaks down into aluminium hydroxide as well as aluminium 3+ and hydroxide, or OH- ions, but not fully. We represent this not full dissociation by using what's called an equilibrium arrow, which is the arrow you can see in the equations regarding weak dissociations. This represents that the equation goes back and forth to show that it doesn't fully go into that full dissociation, like those strong ones do. It's important to remember that concentration and strength are two different terms when regarding solutions of acids and bases. Whilst the strength of an acid or base regards how much it dissociates, so how easily it breaks down into those H+ and OH- ions, concentration relates only, and that's only, to the number of particles present. So if something is concentrated, that means a lot of particles are present in that solution. Whereas if something is dilute, that means not many particles are present in that solution. What this leads to is the fact that you can have both diluted strong and weak acids and concentrated strong and weak acids, as the concentration is only the number of particles, where the strength is how much it dissociates. So you can see the examples now on the right. A diluted strong acid, fully dissociated, but only a few particles present, whereas a concentrated strong acid has lots of particles present and full dissociation. Whereas in our example, a dilute weak base, not many particles present and not full dissociation, and a concentrated weak base has lots of particles present, but still not full dissociation. Thanks for watching. Hopefully now you have a really good foundational understanding of acids and bases. Be sure to like this video, share, and subscribe for future maths and science content. Hope to see you back again soon.